For lesson 3.6, we are going to learn about another new method of factoring called cube factoring. So we have factored using a GCF, we have factored using difference of two squares, we have factored trinomials using the diamond method, we have factored trinomials with a coefficient using the bottoms up method, and we have factored using grouping when our polynomial has four terms in it. So today we're going to be factoring cubes, which means we're going to be factoring terms that have an x cubed in them. So your exponent is a 3 instead of a 2 for the first one. So as always, when factoring cubes, you want to check for a GCF first. That's a given no matter which method you're going to end up using. And then an acronym to help you remember how to factor using cubes is SOAP, which stands for same, opposite, always positive. Now SOAP, that same, opposite, always positive refers to the symbols in between your sets of parentheses as you're setting them up. So we have two different types of cubes. We have a sum of two cubes, which means you have a cube, A cubed, and you are adding a second cubed, B cubed. So the way that I always set this up is you have two sets of parentheses, and I always fill in my symbols first, and that's where the SOAP comes in. So the same refers to your first symbol is the same as the original in the problem. The second is the opposite, which is the opposite of your problem. So in this case, the opposite of addition is subtraction. And then the last symbol is always positive. And you fill in the terms in between each of those symbols the same way always. The cube root of what is in your original problem for each of them is in the first set of parentheses. And then that term squared is the first in the big parentheses. You take each term and multiply them in the middle, and then the last term squared is what comes last. And the idea is exactly the same for the difference of cubes. The only thing that's different is the order of your symbols because of the original problem has subtraction. So you would still have the same, opposite, always positive, and you fill in the variables exactly the same as you did above. So let's look at example 1. For example 1, I have x cubed minus 8. So because these are being subtracted, it is a difference of cubes, but I always want to rewrite the problem so that I have bases. So if you look back up at the difference of cubes, you have a base a to the third power and a base b to the third power. In my example 1, I already have the first one written as a base. It's x. But 8 is not written as a base to the third power. So we need to figure out what 8 is written to the third power. So I'm going to rewrite this as x to the third minus, and we know that 8 is 2 to the third power. So this problem is exactly the same as x to the third minus 8. It's just rewritten. But now I see my bases are x and 2, so I'm going to use the difference of cubes. So the way that I set this up is I set up a small parentheses and a larger parentheses, and the first thing I do is I fill in all of my signs. So it is the same, opposite, always positive, and then we fill in the blanks. So if you look back up at your difference of cubes up here, the very first small parentheses is just the bases. So it's just x and 2. My first blank in the big parentheses is the first base squared. So that's going to be x squared. And my last parentheses is the second base squared. So that's going to be 2 squared. And then my middle is both of the bases multiplied together. So x times 2, which gives me 2x. Now before I box this as my answer, I want to make sure that it's simplified all of the way. So that's going to be x minus 2 times x squared plus 2x plus 2 squared is 4. Now the trinomial at the end looks like a diamond method, but if you tried to do diamond method on that n trinomial right here, there are not two numbers that multiply to 4 and add up to 2. And that larger trinomial is always going to be factored as much as possible. So whenever you're using cubes, you will never be able to factor the trinomial any more than it already is. So let's look at the next one. Example 2, I have a to the third, b to the third, plus c to the third. I want to get this first one written as just one base to the third power. So I'm going to rewrite a to the third, b to the third as ab, all of that to the third. So I just took out the third power and put it on the outside so that now my base here is ab plus c to the third. So because this is a sum of two cubes, I'm still going to set up my parentheses, a small one and a big one, and then I'm going to fill in my symbols using SOAP. So same, opposite, always positive, and now I'm going to fill in the blanks. The small parentheses is always just the bases, so AB plus C. My larger parentheses, the first blank is the base squared, so that's AB squared. And the last base, or the last blank, is the second base squared, so that's C squared. And then the middle is all of them multiplied together, so that's going to be A times B times C. So I want to simplify this a little bit more before I continue on. So that's going to give me AB plus C times AB, all that to the second power is A squared, B squared, minus ABC plus C squared. And that is my factored answer. Example 3, I have 125 plus 27x cubed. So I need to rewrite this first so that I have my bases. So let's first look at 125. 125 is the same as 5 to the third power. So now I have a base of 5 plus. Now if I look at 27x cubed, this is x cubed, but 27 is not part of my base because it doesn't have a cube attached to it. So we can rewrite this as 3x, all of that cubed, so that my base is now 3x instead of just an x cubed, because 27 is 3 to the third power. And if we look at this and think about it, 3x times 3x times 3x, 3 times 3 times 3 gives me the 27. X times x times x gives me the x cubed. So I did break it down so that I have just one single base. So now I have a sum of two cubes. So I'm going to set up my small parentheses and my big parentheses. Same, opposite, always positive. And now I'm just going to fill in the blanks. In the small parentheses, the blanks are just the bases, so 5 and 3x. The first in the big parentheses is the first base squared, so that's 5 squared. And the last one is the second base squared, so that's 3x squared. And then the middle is the two of them multiplied, so 5 times 3x. So we definitely need to simplify this one before we actually can say this is our answer. So 5 plus 3x, and then let's do all of our multiplication at the bottom. 5 squared gives me 25, minus 5 times 3x is 15x plus 3x squared is 9x squared. And that's as factored as you can get, so that's going to be your answer. Example 4, we have 12 minus 12x to the third. So this looks like it might be a difference of two cubes, but 12 is not a cube. But I do notice that both of them have 12. So the first thing I'm going to do is pull out the GCF of 12. So that's going to leave me with 1 minus x cubed. And now I actually do have a difference of cubes because this is going to give me 12 times 1 cubed minus x cubed, because 1 cubed still leaves me with 1. So now I can use this form to apply my cube factoring. So remember, you always need to bring the GCF down. It does not go away. And then you're going to set up your parentheses. Same, opposite, always positive. So I'm first going to put in the bases only of each one. So that is a 1 and an x. And order does matter here. And the first and last term of the big parentheses are each of the bases squared. So that's going to be 1 squared and x squared. And then the middle is always the two of them multiplied. So that's going to be 1 times x. So when I simplify all of that, that's going to give me 12 times 1 minus x times 1 plus x squared. And like I said before, that is as factored as they can be. So you are done. Example 5, I have 3y plus 81y to the fourth. So I'm going to pull out a GCF first. I notice that both of these have a GCF of 3y. So when I factor out a 3y, that's going to leave me with 1 plus 27y to the third. So now I want to rewrite this so I can actually see what my bases are. So this is 3y times 1 cubed plus 27 is the same as 3 to the third. So that's going to be 3y, all of that to the third power. So I'm going to bring my 3y GCF down and then set up my big and small parentheses. Same, opposite, always positive. The first blanks are always just the bases. Nothing is done to them. Then I move on to the first and last. So this is 1 squared and 3y squared. And then the middle is the two of them multiplied. So 1 times 3y. So when I simplify, 3y times 1 plus 3y, 1 squared is 1 minus 3y plus 3y, all of that squared, is 9y squared. Example 6, I have x to the 6th power minus 8. So I want to rewrite this so that I have everything with a base in terms of cubes. So I need to figure out what times itself 3 times will give me x to the 6th. If I take x squared and multiply it 3 times, I add the exponents, which gives me x to the 6th. So this is actually x squared to the 3rd power minus 2 to the 3rd power. So my base this time is x squared and 2. So I'm going to set up my small and my big parentheses. Same, opposite, always positive. In the first set of parentheses is just the bases, nothing is done to them. So x squared and 2. The first blank is the first base, x squared, squared. And the last blank is the last base, which is 2 squared. And then the middle multiplies both of them together. So that's 2x squared. So when we simplify, x squared minus 2, x squared to the second power is x to the fourth, plus 2x squared plus 4. Example 7 is exactly like the last example that we did yesterday. The only thing that's different is the volume that I give you is a little bit different. So let's read the problem. The volume of a rectangular prism is 2x plus 16 plus x cubed cubic inches. Part A, I want to know if the height is 2x inches, find the area of the base. And part B, I want to know what are a possible length and width of the solid. So remember, like we talked about yesterday, volume is equal to length times width times height. And area is equal to length times width. So we could also say that volume, in part A, is equal to the area times the height, because I can substitute area in for length and width since they're the same. So now let's actually plug in what we know. Volume was given to me. It's 2x plus 16x cubed equals, I don't know what the area is, but I do know that the height is 2x inches. So all that I have to do for the rest of this part is to get the area, which means I just need to get A by itself. I don't even have to solve for x. So I'm just going to divide everything by 2x. Hold on a second, guys. This was supposed to be an x to the fourth. So this should be 16x to the fourth power. So then when I divide by 2x, 2x divided by 2x leaves me with 1. And 2x divided by 16x to the fourth is plus 8x to the third equals area. So I had made a typo on here. It was supposed to be a 16x to the fourth, not to the third, so that way when I divide by 2x, then I get 8x to the third. So 2x divided by 2x left me with a 1, and 16x to the fourth divided by 2x, 16 divided by 2 leaves me with 8, and x to the fourth divided by x left me with x squared, and that is the area. So to find the volume, to find the length and the width, I know that area is equal to length times width. So I need to take that area that I found in part A and break it up into two different quantities, a length and a width. So I'm going to rewrite this first because I notice that this is written as a sum of 2 cubes. So I have 1, which is the same as 1 cubed, and 8x, all of that to the third, is the same as 2x to the third power. So my two bases here are 1 and 2x. So I'm going to set up a small and a large parentheses, same, opposite, always positive, and then fill in the blanks. So my first bases go here, 1 and 2x. First blank is the first base squared, and second blank is the second base squared. And then the middle is the 2 multiplied together. So when I simplify this all of the way, that leaves me with 1 plus 2x times 1 minus 1 times 2x is 2x plus 2x, all that to the second, is the same as 4x squared. 1 is your width and 1 is your length. We don't know which one's which, and it doesn't matter, so you can just leave them the way that it is. And that is our newest factoring method, which is factoring by cubes. So you need to remember the SOAP, same, opposite, always positive, and filling in your blanks, and that's always going to be as factored as you can get the entire problem.